Okay, so we're going to do lecture on section 2.1, and it is assumed that you've had pre-calc, that you've had this idea of a limit, of a secant line. Is this a secant line right here? Secant line is something that goes through a curve, so that's going through a curve. Can you take the slope of a regular line? We know how to do that, right? We have a slope formula. But can we take the slope of a curve? Can we take a slope of this curve at a certain point using calculus? We can do that. So we're going to talk about the secant, and we're going to end up talking about the tangent line. So this is the start of what we're doing. In this picture, we've got x and f of x. And we've got x sub 2 and f of x sub 2. We've gone this distance this way. And I don't know if you can see that. Maybe I need to make it a little bit bigger. Is that better? Okay, so we've gone this distance. What is that distance? We're going to call it h, or delta x, the change in x. Okay? So, down here. I was plugged in. Okay, there we go. Sorry. Okay, the average rate of change, delta y over delta x, is the change in y, which is what f of x is, over the change in x. Is that essentially the slope formula? The change in y over the change in x? That's what that is. This is also another form of that. Do you remember from college algebra doing the difference quotient, where you had f of x plus h minus f of x over, and then it was x minus h, all of that. And when I teach college algebra, I tell them, you know, they just want to learn it because it's the thing they have to learn in college algebra. And I said, you're going to see it again in calculus. Well, here we're seeing it. So average rate of change with respect to x over some interval, we can use this idea. Sometimes we won't have to use that idea. If we've got a straight line, we can just do average rate of change. But if we have a curve, we're going to have to do this. So let's look at an example, and I'm going to go back down so we can get all of that on the screen. I think I just wrote on the deal. All right. I just wrote on that. Go away. All right. Find the average rate of change of the function over the given interval. So we've got f of x equals x cubed plus 1. And we want to know about the given interval from 2 to 3. Okay? So you're given some x values, and what are we doing? We're just plugging in. We're the change in y over the change in x. That's the average rate of change. The average rate of change. That isn't the slope. That's the average rate of change. So if we did f of 3 minus f of 2 over 3 minus 2, double check my math. Make sure that you get that same number when you do it. You can always check me. Did we get 19? Somebody? Did anybody do it? No? Okay. Okay. What about if you had this one? This is a trig one. Those of you who have had trig or pre-calc, you've had some recollection of these functions. Every time we do something, we'll do some of it with trig. So that trig's going to become important to you. If you don't remember it, you need to start looking at it. Okay? H of x is cotan of x over the interval pi over 4 to 3 pi over 4. In degrees, what's pi over 4? 45. 45. Not that you have to think in degrees, but sometimes it's helpful. All right, so if we did h of 3 pi over 4 minus h of pi over 4 over those x values. Okay. Cotan of 3 pi over 4. You probably don't have that memorized. I don't necessarily have it memorized. Something that could help you as you get started, and I think I put it out there on handouts, is this trig identity sheet. It's a really nice one at the bottom. You guys should recognize it. It has all the trig values for the common values. So if you went to cotan and you went to 3 pi over 4, you'll see -1. Bam, you got it. It's not that you might not get to use this, but it'll help you ease back in, okay? You could also, could you go on your calculator and do it? You could. You could. It's the, you know, the opposite of tan. But anyway, it is -1, so we're going to take my word for that at this point. So we have -1 minus 1, which is 2, and then 3/4 minus 1/4 is what? 2/4 or 1/2, so we'll call that pi over 2. So we have -2 over pi over 2. Flip that bottom fraction and we get -4 over pi. Generally, what do you recognize that you have to be pretty good at remembering? Not just the trig, it's your algebra. You know, the calculus is not going to do you in. Sometimes the problems will be the algebra. When I was working something the other day for this course, I couldn't get the final right answer. I was missing one little term. It was a long problem. I was like, okay, I've done this, and I couldn't see. I had a negative wrong, which made my whole thing wrong. And so you really have to be careful, and you have to be good with your algebra. Okay, so now let's talk about a curve. The slope of a curve. We're going to use the slope of a tangent line. A tangent line, unlike the secant lines that go through, tangent comes in, that's this red guy here. Get it bigger. Okay? That red one right there is coming in at the curve and hitting it at a point. These secant ones are coming in and going through. So we're going to talk about that tangent line. It's going to be special. Let me get back here. All right, it says we need an approach that takes into account the behavior of the secants through P. So they're going through point P and nearby points Q as Q gets closer to P. Okay, so Q's here, but then it's here, and then it's getting closer as we move that secant, if we have different secant lines. Investigating the limit value of the secant slope as Q gets closer to P, that's going to get us the limit. And we're going to get really deeper into the limit in the next section. But I did this problem in pre-cal. Do you guys remember when we did that, when we were starting the limits? Has anybody seen this problem where you're talking about the tangent of a curve in pre-cal or something? It's really an important idea that's how we're going to talk about the slope of a curve. It's the slope of the tangent line. And we're going to be dealing with a limit. Okay? If the limit exists, you take it to be the slope of the curve at P and define the tangent to the curve to be the line through P with that slope. So, in this particular section, we're going to do some of that average rate of change. We're going to do some of it where we're having to do the f of x plus h. And we're going to do some of it where we're going to write the equation of the tangent line. Okay? So, example. Let's do an example here. Find the slope of the curve at the given point in the equation of the tangent line. Okay, so here's this curve, and when you're given this point, those are the coordinates. X is 2, f of x is 1. So we're going to say, okay, we don't know what Q is, but we're going to say we moved some distance h. So we'll think of Q as whatever your x value is plus h. And the y value of Q would be f of 2 plus h. Does that make sense? We don't know what Q is. Here's P, and we're saying this is Q up here, and that we've moved some distance h. So if this is x plus h. Well, we know x is 2, so this is going to be 2 plus h. Does that make sense? Sort of. Okay, so if we accept that we're going to use that for Q, then we can find the slope of the secant line between P and Q. So here we go. Delta y, delta x. That's the change in y over the change in x. And we use, here's our Q point, 2 plus h squared. I'm going to put that, I'm putting it in here, okay? 2 plus h squared minus 3. That's in my first part. And where did I get this minus 1? Is that your other y? That's that point right there. So you plug in your x value plus h over here, and this is f of that. So we're going to have minus 1 over, and down here it was the two x's subtract each other. So we had 2 plus h up here. We had 2 plus h here, and we had 2 here. So if I subtract the x's, I have 2 plus h minus 2. Well, what happens to the 2's? Cancel out. So on the top, we got to square this thing. So when you're squaring a binomial, just remember that little, I give people a shortcut. If I'm going to square this, it's this one squared, that's 4. This one squared is h squares. The middle term is that times 2. 2 times h times 2, so 4h. So there we go. Minus 3 minus 1, so we get minus 4. Everybody good there? Those cancel. And now I'm left with 4h plus h squared over h. What happens to the h's? Cancel. And I get 4 plus h. And all of this, really, I'm going to take the limit. I'm taking the limit as h gets to 0. As that distance between p and q gets closer to 0, what's happening? That's what I'm asking. So the limit as h, which is my difference, goes to 0 of this thing. Well, what happens if I plug in h for 0? I'm left with 4. So the slope at that particular point is 4. So we did all of this to get the slope. So the slope is 4. We were asked to find the slope. What else were we asked to find? The equation of that tangent line. So what do you need to write an equation of a line? Slope and a point? We have both of those. All right, we have the point 2, 1, and we have m is 4, because we just found 4. And we use y minus y1 equals m times x minus x1. Okay? Plug in the parts that we have, which are here, 1, 4, and 2. And then clean that up, and you get y equals 4x minus 7. That's the equation of the tangent line at that particular point. The slope of the tangent line is the limit as h goes to 0. As that distance between those 2 points, p and q, yeah. So the slope in a curve is the limit. The slope of the tangent is like, we're going to do it with a limit process. Now, how many of you have had calculus in high school? Okay, so you're sitting there going, I know all this junk, but I know how to take derivatives. I know how to do the slope of the tangent. I don't want to do this. Unfortunately, in Cal 1, we got to do this stuff before we get to the easier way to do it. So bear with me. Long ago, I was right where you were, and I didn't know the first time I took it, because I didn't have it in high school. They didn't even offer it. That's how old I am. But the first time, and it was pages and pages of this kind of stuff. And then when they showed me all those shortcuts, I was just angry. It's like, why did you have me do that? But it's important to get the process. Okay? All right, let's look at the problems. Let's work through problems. Okay. We will have to make that a little bit, although you have it. Let's see. All right. Find the average rate of change of the function over the given interval. Okay? So, do we have to do anything with the x plus h at this? This is average rate of change. We can just plug in those numbers like that example that we did. So let's do that. Okay, so here's the first one that we're doing over the interval from 1 to 3. So what do I write? Not in yellow. F of 3 minus f of 1 over what? Change in y over, yes, 3 minus 1, which is the change in x. And so then you're going to plug in 3 to get your f of 3 value. You're going to plug it in here. You're going to plug that in, and you're going to get those two numbers. Okay, so you can do those calculations and come up with a number. You should come up with a whole number, so I will let you do that. Okay, what did we get? 78, because you had 156 over 2 or something. Okay, so that's the first one. That's A part. Okay, so when you go to do your homework, that's exactly what you're going to have to do on that one. We have a B part that says -6 and 6. You're going to do it exactly the same way. You're going to have f of 6 minus f of -6 over 6 minus -6. Be careful with your parentheses so that you don't mess up your signs. Okay? And so this is when your calculator comes in handy to get you an answer. Be sure when you're cubing something, if you're doing it on your calculator, that you do put it in parentheses, or you won't necessarily get the right sign. When you cube a negative, what should you get? Negative. Okay, so what's our final answer? Maybe? Anybody? Trying? Do y'all have it? Oh. All right, somebody has a calculator, somebody's doing it. I think that's it, but I'd like some verification. Good. 216? Okay, good, good. It will be helpful for you to have your calculator, or at least a calculator app on your phone. That graphing calculator app's pretty good. Okay. All right. Okay, let's do number 2. It is find the equation for the tangent line to this equation at this point. Okay? So, while if you know calculus, you could get the slope of that real quickly, but we need to do the work. Now, you're on your homework, and if it's not a show work, you're going to do it whatever way you're going to do it. But on the test, you are definitely going to have to do a problem where you have to do that. So it'd be worthwhile to practice. Okay, so let's think about, we've got P, that's this point right here, and let's think of Q as -3 plus H and F of -3 plus H. So that's the kind of the way you want to think about this. okay, when you're trying to find the slope. Okay. All right, so what am I going to do? F of this, what do I have to do? I have to plug this negative 3 plus h in here. So I've got negative 5 minus 7 times what? Negative 3 plus h squared. So I just substituted this right here in here. Where there was an x, that's what got put there. Okay? Minus, what goes here? This is one y value. What's my other y value? Negative 68. Okay. All right. So that's the difference in the y's. And what do I put down here? Difference in x's. Minus what? Negative 3. Here's the x value. Like, here's an x value. Here's a y value. And so on the top, we've got minus a negative 68, and on the bottom, we've got minus a negative 3. And that's just the slope formula using these points here. All right, so let's go ahead and work that out. Negative 5 minus 7 times. We got to square this. So what are we going to get? 9. Okay, you got plus h squared here. What's our middle term? Minus 6h. A lot of times people forget that middle term, and that will mess you up. Okay, minus a minus, so we've got plus 68 here. On the bottom, what happens? What are we left with? H. Okay, so we're just cleaning it up as we go along. Now I got to multiply 7 times this stuff. Negative 5 minus 63 plus 42h minus 7h squared plus 68 all over h. Okay. What are you noticing on the top? Yeah. These guys cancel. Okay. So I'm left with 42h minus 7h squared over h. Can I factor that? Okay. 7h times, oh, I don't want to take out 7h. I'm not really just factoring. Sorry. Is that right? Okay, now, you wanted to do that because you are taking the limit as h approaches 0. And you couldn't do that if h were on the bottom, right? So this is good. We have to get h out of the bottom, and that's now gone. So we've got 42 minus 7h. So what do we get when h goes to 0? 42. So that's our slope for this line. Okay? So that's our m. We have to write the equation of the line. Do we have what we need for that? Okay. Yes. Okay. Whoa. When you are taking the limit, and I'm assuming that we kind of know, remember that. That was a bad assumption on my part. When you're taking the limit and it's something like this, you can just plug the value in as long as it doesn't become undefined. Well, up here, if I were taking the limit and h were on the bottom, could I do that? I can't do that because you'd be dividing by a fraction. I mean, you'd be dividing by 0. Do you remember that? Okay, but just algebraically, we can't have 0 on the bottom of a fraction, okay? So when you're taking the limit and it's a polynomial, we can just usually substitute directly in if algebraically we don't run into a problem. Well, we ran into a problem. So I factored it, got rid of those h's, and now I'm just plugging in 0 for h. As h becomes 0, that goes away. Now it clicked? Okay. I was going around the world, and I didn't need to. All right, so we've got an m of 42. What was our point? What was it? Okay, so we've got that, and we've got m is 42. So we're going to write our equation of our line. Y minus y1 equals m times x minus x1. So y plus 68 equals 42 times x plus 3, and then you clean it up. What is that? 58. So let's talk about the process we used. We have to use that limiting idea to get the slope. Think of you're given a point with an x and a y. The x value of this other point over here, this q, is going to be whatever your x value is plus h, and then f of that x plus h. So we have to go through this. There'll be a time when we don't have to do that, but right now we do. Okay? All right. So this one's yours to do. Okay, so the equation of the line was y equals x minus 6. Did we get that? Got the slope? What I saw, some of the questions that I saw was missing this right here. And I think it's crucial that when you write out your problem, think of it as a road map. If you don't put all the parentheses in, you're going to miss a sign. A lot of people didn't make this 3h negative. And if you make it positive right here, well, you don't get the right answer. So that minus 3, that's just basic distributing, but we miss it all the time. So be sure you put things in parentheses, that you bracket things, and that you do things in the algebraic correct order. Okay? All right. So everybody get this? Or we're getting there? Okay. We'll go back to the blank ones. All right. Okay. So we did number 3. All right, how about number 4? Let's make... Oh no. All right. This graph shows the profits of a small home business for the years of the decade of the 90s. Find the average rate of change of profits for the interval specified and the rate at which profits were changing. We're steadily moving into the idea of finding change at a particular point. Instantaneous change. That's where we're headed. But let's just do this. Right now we're doing average rate. Okay, average rate of change of profits for the interval between year 2 and year 4. Okay, well, do we need calculus for that? We're talking about this point and this point. Do we have some x values and some y values? Okay, so from 2, what's the y value for 2? 2. And then for 4, 8. So we can find the average rate of change between those. We can call that the change in profit over time equals 8 minus 2 over 4 minus 2, which is 6 over 2, or 3. Does that make sense? That's the average rate of change, and it says it's per thousands, so that's 3,000 per year in those years. So that's the first thing there. Okay. Now, the rate at which profits were changing in year 7 of the decade. In year 7, we don't have anything else to go. Here's a suggestion for how to do that. Could we do the average rate between 6 and 7 and the average rate between 7 and 8? You do that. Come up with what you got. It's the same idea. You're using the graph. You're going to have some decimals in this one. Six 7 is 24.5. So those are the 2 points associated with 6 and 7, and you're just finding the slope. And you can tell me what you get for an average rate of change. 6.5? Okay, so we have 6.5. And now do it for 7 and 8. Faster than I can write. Was this 32? Okay, so if we have 6.5 and 7.5, where does 7 fall in that? Is it kind of halfway between? So the rate, how did they word that? At which the profits change in year 7 is approximately 1/2 of 6.5 and 7.5, which is what? 7. So we'll just put it in thousands. Okay. Is that okay? Just kind of had to have a thought process there. You'll have a problem with a graph on your homework, and you should have that process down. Okay. Questions? Anybody? All right. I think the next one goes back to actually being easy. So we can skip that one. That's average rate of change over the given interval. Is that just plugging in numbers? F of 7 minus F of 4 over 7 minus 4? We could do that. And the work is already written out for you. But what about this one? Same idea. There's a little bit of fraction stuff here, which might, I don't know if it'll mess you up. Why don't you try this one? Average rate of change over 4x squared from 0 to 7 over 4. That's number 7. Number 7. It's a multiple choice question. So you've narrowed your problems there. Let's see if you can do it. What do you do when you square a fraction? Not doing it on the calculator. Yeah, square the top, square the bottom. Okay. And what do you do when you have a complex fraction? Flip the bottom one and multiply. So you've got 196 over 16 times 4 over 7. I think a bunch of stuff cancels out. Okay, so that's not a hard problem. I just wanted to remind you of working with fractions, because you'll have some really complex fractions that you'll encounter. Okay? Okay. Anybody have a question on that? No, no. How did I set it up here? Okay, remember that's f of 7/4 minus f of 0 over 7/4 minus 0. And so to get f of 7/4 means you plug 7/4 into the function. So it's just the y's, the change in y's over the changes in x. Is that better? Yes. When you're doing intervals, this should be the far end. That should be, you might run into some trouble at some point, so I would say start with this one and subtract the other one. Because you're talking about intervals. Okay. Let's do this tan 1. And I took out number 9, I think, out of your homework. Why did I do that? It's a good one. But I think you'd already done enough of those, so maybe not. So let's just do this one, and we're going to do the average rate of change, but we've got 2 plus tan t from negative pi over 4 to pi over 4. Does anybody remember what the tan of 45 degrees is? 1. Okay, yeah. Sine of 45 is square root of 2 over 2. Cosine's the same thing, and tan is 1. So that's going to be helpful for you. And negative pi over 4, what quadrant is that? Fourth quadrant. Is tan positive or negative there? It's negative. Yeah, tangent's positive in the third quadrant. So it'll be negative 1. Okay, so that's the thought process that has to go on there. So we will have finished that, and we're marking out that one. Okay? All right. I think that'll conclude that one. So we'll